Question number 1. Assume that the following confidence interval for the difference in the mean length of male, which is sample 1, and female babies, sample 2, at birth was constructed using independent, simple random samples. What does the confidence interval suggest about the difference in length between male babies and female babies? We have here negative 0.2 inches, and we have here positive 1.7 inches. But remember that between that negative and that positive is also 0. That means it could be 0. There is not really any significant difference between the two values in this confidence interval. Construct the indicated confidence interval for the difference between the two population means. Assume that the two samples are independent, simple random samples selected from normally distributed populations. We have everything we need. Also assume that the population standard deviations are equal, so that the standard error of the difference between mean is obtained by pooling the sample variances. A paint manufacturer wanted to compare the drying time of two different types of paint. Independent simple random sample of 11 cans of type A and 9 cans of type B were selected and applied to similar surfaces. We know they're definitely independent because they have different amounts. The drying times and hours were recorded. The summary statistics are as follows. Construct a 99% confidence interval for mu1 minus mu2. The difference between the drying times for paint type A and the drying time for paint type B. Go to Stat, T-Stat, to sample with summary, and I put my information in. For sample 1, my mean is 71.5. My standard deviation is 3.4, and my sample size is 11. For B, it is 68.5, 3.6, and 9. Obtained by pooling the sample variances. We get pooling, and we're looking for a confidence interval. First, let's see what our H0 and H1 are, because we do need to know whether or not this is a one-tailed test or a two-tailed test. We're looking for the difference between the two drying times. First, mu1 minus mu2 equals 0. Two not equal to 0. We have a two-tailed test. Our confidence interval is 99% and compute. My lower limit is 1.51. My upper limit is 7.52. But I think this is the closest I can come. Check answer. And there we have it. There's something a little tricky here. We have a two-tailed test. Our confidence interval stays the same as what we're trying to construct here. And if it's 99%, we have 0.005 over here and 0.005 over here. If I do it with two tails, I multiply it by 2, and I get our significance level, which gives us our confidence interval. If I have a one-tailed test, let's say it was greater than, then this would be 0.01. And because I have two samples, I would also multiply this by 2. Now I get 0.02, which is a 98% or 0.98 confidence interval. We'll see that in our homework problems. One tail for our confidence interval would be 2 alpha. If I have a two-tail, our confidence level is equal to alpha. A paint manufacturer made a modification to the paint to speed up its drying time. Independent simple random samples of 11 cans of type A, the original paint, and 9 cans of type B, the modified paint, were selected and applied to similar surfaces. The drying time in hours were recorded. The summary statistics are as follows. The following 98% confidence interval was obtained for mu1 minus mu2, the difference between the mean drying time for paint can type A and the mean drying time for paint can of type B. What does the confidence interval suggest? Now, we're not being asked to actually find the confidence interval. We're given the confidence interval and we want to know what it's saying. Type A is mu1 and type B is mu2. Then if mu1 is greater than mu2, then mu1 minus mu2 would be greater than 0. If mu1 is less than mu2, then mu1 minus mu2 would be less than 0. I have my confidence interval, mu1 minus mu2. Everything there is greater than 0. Since it's greater than 0, paint type A takes longer to dry than paint type B. The confidence interval includes only positive values, that's true, which suggests that the two population means might be equal. That's not what it says. It says that mu1 is greater than mu2. I don't see how they're equal. They would only be equal if one was negative and one was positive and there was a 0 in between. But it's not that. The confidence interval includes only positive values, which suggests that the mean drying time for paint A is greater than the mean drying time for paint B. The modification seems to be effective in reducing drying times because we modify type B. That looks like the right answer. Let's just read the other ones. The confidence interval includes only positive values, which suggests that the mean value type drying time for paint A is smaller. No. If it was smaller, then it would be negative. And confidence interval includes 0, which it does not. We can rule that out. Check answer. Perfect. Listed in the data table are amounts of strontium-90 in milli, whatever that is, or MBQ per gram of calcium in a simple random sample of baby teeth obtained from residents in 2 cities. Assume that the 2 samples are independent, simple random samples selected from normally distributed populations. We got all our requirements. Do not assume that the population standard deviations are equal. We do not want pooling. That's what that means. The only way we want pooling is if they're equal. Use a 0.05 significance level to test the claim that the mean amount of strontium-90 from city number 1 residents is greater than the mean amount from city number 2 residents. We have H0, mu1 is equal to mu2. And our alternate hypothesis, the claim is that the mean amount from city 1 is greater than the mean amount from city 2. Mu1 is greater than mu2. But is this a one-tailed test or a two-tailed test? This is a one-tailed because we're greater than. We're not looking at the left side, we're only looking at the right side. I'm going to go to stat, T-stat, to sample with data. City 1 is values in sample 1, and city 2 is values in samples 2. We already were told that we can't pool our variances. Then we're going to match these. If mu1 equals mu2, then mu1 minus mu2 equals 0. If mu1 is greater than mu2, then mu1 minus mu2 has got to be greater than 0. Compute. Here's my t-stat. 2 decimals, My p-value to 3 decimals, 1, 2, 3. That's going to end in an 8. Check answer. Was my p-value greater than or less than or equal to my significance level, which is 0.0, and my p-value is 0.078. That's greater than 0.05. If I were to look at it on a curve over here, this is 0.05. This is my rejection area, but I'm not in that area because only things smaller than 0.05 would be in there, and 0.78 is bigger. This is the fail to reject. There is not sufficient evidence, that's true, to support the claim that the mean amount of strontium-90 from City 1 residents is greater. Yes, I can't reject it because I'm not in my rejection region. Fail to reject. There is sufficient evidence. No. When I fail to reject, I don't have enough evidence. I only have enough evidence when I can reject the null hypothesis. A is the correct answer. A study was done using a treatment group and a placebo group. The results are shown in this table. Assume that the two samples are independent, simple random samples selected from normally distributed populations. We have our requirements. And do not assume the population standard deviations are equal. That means no pooling. We want to complete part A and B below. Here's my significance level for both parts. Stat, T-stat, two sample with summary, because they're only giving me summary data here. My mean is 2.32. My standard deviation is 0.57, and my sample size is 25. For sample 2, my X bar is 2.67. My standard deviation is 0.85, and my sample size is 30. We are not pooling. I didn't get the null and alternative hypothesis. We know that the null hypothesis always has to be that they're equal. What's the claim? That the two samples are from populations with the same mean. My claim is that they're equal. My alternative would be that they're not equal. That's a two-tailed test. I click that and check. Perfect. The test statistic. I get my test statistic from my hypothesis test. This one is mu1 minus mu2 equals 0. And then this one is they're not equal to 0. We hit compute and we get our t statistic. And my p-value to 3 decimals. That's my p-value. And now what's our conclusion? We look at our p-value. Is it bigger or smaller than our significance level, which is 0.10? It's definitely smaller. That means it's going to be in the rejection region. State the conclusion for the test. Reject the null hypothesis. We can only reject if we have sufficient evidence. There is sufficient evidence to warrant rejection of the claim that the two samples are from populations with the same mean. We reject that. We want our confidence interval. Now, this is a two-tailed test. Listen carefully. Remember I said that if it's a two-tailed test, you use the given significance level. If it's a one-tailed test, you have to use 2 times the significance level. Now for this one, I would have 0.90. That's because I have a two-tailed test. If I have a one-tailed test, it would be 0.80 because we double that significance level. We hit compute. This is our lower limit to 3 decimal places. That last number is going to be a 3. And my upper limit, check answer. I want to show you that here we rejected the null hypothesis, which meant that the sample means they're not equal. This shows me that mu1 has to be smaller than mu2 because everything here is negative. I'm not going to completely do this because it is in your homework, but I did want to show you something that I didn't think that you knew. When I click here, I'm only getting part of my information. You saw before that when I go to stat and tstat and to sample, I either pick with data or with summary. But here I have data on the left and summary on the right. What do? Well, the best thing to do is go to summary stats column, and we want bar 1. And what do we need? We need n, we need the mean, and we need the standard deviation. I can come here and I can store the output. There's my n, my mean, and my standard deviation. Now, I can compare summary data. You have the summary data from the left side, and you have the summary data from the right side. And from here, I'm going to let you guys finish this problem. Good luck. And if you have any questions, please feel free to ask. Have a good one.